find out how it is to be done. अब जो questions है बेटा, इनमें there is no formula which you can apply. You have to think out what will be the solution of that question. इसके लिए आपके माइंड में रैशनल होराइजन डायग्राम का कॉन्सेप्ट जो है ये क्लियर होना चाहिए. सो दिस इज व्हाट वी आर गोइंग टू लर्न टुडे. ये पहला चीज है जो आज हम लर्न करेंगे. सो दैट इज टू अंडरस्टैंड द कॉन्सेप्ट ऑफ रैशनल होराइजन डायग्राम. So today is going to be a theory heavy class. You want to keep a cup of tea or coffee close to you, most welcome, you can keep that so that you don't fall asleep. So इसमें मैं आपको पहले थोड़ी celestial sphere की understanding बताऊंगा, जिसमें हम समझेंगे इक्विनॉक्शियल क्या होता है, पोल्स क्या होते हैं, ज़ेनिथ और these things. Then हम जाएंगे होराइजन सिस्टम में. होराइजन सिस्टम में हम देखेंगे जेनिथ क्या होता है, नादिर क्या होता है, रैशनल होराइजन क्या होती है. And then we are going to combine these two systems and वहां से फिर निकल के आएगी रैशनल होराइजन डायग्राम और उसके साथ ही कॉन्सेप्ट आएगा PZX ट्रायंगल का. सो ये हमारा आज के लिए एम है. सो टू अंडरस्टैंड द रैशनल होराइजन डायग्राम एंड द PZX ट्रायंगल. ये थोड़ा सा थ्योरी हैवी टॉपिक है एंड थोड़ा आपको ध्यान देना पड़ेगा. यू नीड टू पे अटेंशन टू मी. सो तभी ये जो है अंदर जाएगा. सो वंस यू अंडरस्टैंड इट देन द पार्ट सी. Let's assume that this circle what we see on the screen represents the earth. So we have the earth on the screen now. Now on earth we have our reference system, which is based on the equator and the poles. We know the earth is rotating about its axis, completing one rotation in one day. And these axes, they pass through the earth's poles, the earth's geographic pole, which are North Pole and the South Pole. So let's mark off the poles in this diagram. The North Pole is here in this particular location. You can see it is represented by NP, and the South Pole is here in this particular location, and you can see it represented by SP. So we have both the poles of the earth marked on our diagram. Now let's show the equator also. Now we know equator is a great circle on the surface of the earth, exactly midway between the two poles. So you can now see the equator in the diagram. So I have marked the equator. The earth is shown at a slightly tilted angle. So that is just to make a clear diagram which is easy to understand. So we have the equator marked in the diagram. It is shown here labeled as equator on our plot. Now once we have the earth, the poles and the equator in our diagram, we can now proceed to understand the celestial sphere. Now you see this bigger red color circle in the diagram. This bigger red color circle represents the celestial sphere. Now to define any sphere, we need to specify what is the center of the sphere and what is the radius of the sphere. So we will specify the center as well as the radius of the celestial sphere also. As you can see from the diagram, the center of the celestial sphere is the same as the center of the earth. So earth and celestial sphere are both concentric spheres. The center of the celestial sphere is same as the center of the earth. Now coming to the radius. The radius of the celestial sphere is assumed to be infinite radius. So the celestial sphere is a sphere whose center is same as the center of the earth and it has infinite radius. Now, what is the purpose or use of this celestial sphere? Now, this celestial sphere is very helpful in solving celestial navigation problems. Now, it is a imaginary sphere. It does not exist in reality. We have assumed this sphere so that we are able to easily calculate the required parameters or the required items which we need, which is basically the position of the ship. So that is what we are interested in. So involving the celestial bodies, the sun, the stars, planet, and the moon. All these four different celestial bodies, we have the sun, we have the moon, we have various stars, and we have four planets which are used for celestial navigation. So involving these objects and finding our position on the surface of Earth, fixing up the ship's position, was made possible only with the assumption of this celestial sphere. As I told you, this is an imaginary sphere. We have assumed it. Now, how does it help us to get the items or solve the questions which we need? How does it help us to find the position? Now, this celestial sphere, as I told you, it is assumed, it's an imaginary sphere. We consider that all the celestial bodies are situated on the surface of the celestial sphere. Whether it is the sun or the stars or the planets or the moon, we consider all of them to be situated on the celestial sphere. Now, once these bodies are considered to be situated on the celestial sphere, we are able to use our knowledge, formulas related to spherical trigonometry to solve them. So we know spherical trigonometry is the branch of trigonometry which works on the surface of a sphere, on the 3D curved surface of a sphere. We have a few important formulas. Just to name, cosine formula and Napier rule are a very important relations or formula in spherical trigonometry. So once you consider all the celestial bodies to be situated on the celestial sphere, we can easily use these formula to calculate the required items which we need for our purpose, or we can use it to fix up the position of the ship. So that was the advantage or the purpose of imagining this celestial sphere. Now, just like we have references on the surface of Earth to fix up the observer's position, similarly, we also have some references on the celestial sphere to specify or fix up the position of the celestial bodies. On the surface of Earth, the references which we use are the equator. We can specify the latitude of a position using the equator. It tells us how much, the latitude basically tells us how much north or south of the equator a particular position is. And the second reference which we use are the meridians. Meridians are semi-great circles passing from the poles, North Pole and the South Pole. We have the Greenwich meridian as our reference meridian, and we have the meridians running 180 degrees east and west of the Greenwich meridian. So they give us a reference to calculate or find out the longitude of a particular position. So this is the reference what we use on the Earth's surface, the latitude and the longitude. Now, how to specify the position of celestial bodies on the celestial sphere? So for this, we have made some references, and they are very much similar to the references on Earth. So let us now see the references which we have on the celestial sphere. Now we know that the Earth rotates on its axis, completing one rotation in 24 hours. Now these axes pass through the poles, the North Pole and the South Pole. So let us mark this axis of the Earth in this diagram. And let us extend this axis to the celestial sphere. So you can see this dotted line. This dotted line basically represents the axis around which the Earth rotates. The points at which it cuts the Earth's surface are the North Pole and the South Pole. They are already marked in the diagram. Now, if you extend this axis of the Earth or you project them up to the celestial sphere, you see the axis of the Earth projected onto the celestial sphere or extended to the celestial sphere meets the celestial sphere at this particular place. Now, this is known as North Celestial Pole, represented by NCP, which stands for the North Celestial Pole. Similarly, the axis of the Earth extended towards the South Pole of the Earth meets the celestial sphere at this particular location, and this is known as the South Celestial Pole. So you have the South Celestial Pole marked on the diagram as SCP. So these are the two celestial poles which we use as our reference. Now, exactly same as we have the equator on the surface of Earth, equator is a great circle which is equidistant and exactly midway between both the poles, the North Pole and the South Pole. Now, in an exact same manner, a great circle on the celestial sphere exactly midway or equidistant from the North Celestial Pole and the South Celestial Pole is known as the celestial equator. So you can see resemblance in the names. We have it as a equator on the Earth's surface, and when it goes to the celestial sphere, we call it celestial equator. Other name which is more common in navigation terms is the equinoctial. So we also call it the equinoctial. The north and south poles, when they are projected onto the celestial sphere, are known as the celestial poles. The equator, when it is projected onto the celestial sphere, is known as the equinoctial. So let us show the equinoctial also in the diagram now. So you can see this red color great circle which is located on the celestial sphere, exactly midway between the north celestial pole and the south celestial pole. This is the equinoctial. So you can see it labeled in the diagram. Now you can also understand equinoctial from a different perspective. If you extend the plane of the equator outwards, the plane of the equator is extended outwards, or you can say if the equator is projected onto the celestial sphere. So you can assume that there is a light source at the center of the earth, and the equator is casting its shadow. A shadow is being cast on the celestial sphere, and that is also known as a projection. So this shadow, wherever it hits the celestial sphere, forms the great circle which we know as equinoctial. So we have the equinoctial in the diagram, we have the north celestial pole and the south celestial pole in our diagram. These are used as reference points to specify the position of any celestial body on the celestial sphere. Now, how do we use it as references? This is also very similar to what we do on Earth. On Earth, we represent a position using its latitude and longitude. Now, latitude is referenced to the equator. The latitude of a place basically tells us how much north or how much south of the equator a particular position is. Exactly in the same way we use the equinoctial. We first find out whatever celestial body we want to specify. how much north or how much south of the equinoctial that particular body is. And on celestial sphere, we call it as the declination of the body. So the job of latitude on the surface of Earth is done by the declination on the celestial sphere. So if you have the declination of any celestial body, it immediately tells you how much north or how much south of the equinoctial that particular body is. So that's how we use the equinoctial as our reference. Now for the longitude of any place on the surface of Earth, we use the meridian of Greenwich. We use the Greenwich meridian as our reference meridian, and we find out how much east or how much west of the Greenwich meridian that particular body is. Now on the celestial sphere, we have two references. One is exactly similar to Greenwich, which is the celestial meridian of Greenwich. What is the celestial meridian? Now, a celestial meridian is very much similar to the meridian which we have on the Earth's surface. The meridians are semi-great circles joining both the poles of the Earth, the North Pole and the South Pole. Now, in the same way, a celestial meridian is also a semi-great circle on the celestial sphere joining both the celestial poles. So you can see a green color dotted line on the screen now, highlighted by the laser pointer. So this dotted green line is a great circle which is passing from both the celestial pole, the north and south celestial poles. Now this is what we call as a celestial meridian. We can have infinite number of great circles passing from both these poles, as these are diametrically opposite points. Now, if we project the meridian of Greenwich onto the celestial sphere, wherever it projects or falls, that is called as the celestial meridian of Greenwich. Now, celestial meridian of Greenwich is used as a reference to specify the position of a body, but we do not use the longitudes on the celestial sphere. What we use on the celestial sphere is GHA, Greenwich R angle. So Greenwich R angle is measured with reference to this celestial meridian of Greenwich, and it is measured in the westerly direction. So just as we have the Greenwich meridian as a reference on the surface of Earth, we have the celestial meridian of Greenwich on the celestial sphere as a reference to specify the position of any celestial body. So if we get the declination and the GHA of any particular celestial body, we will be able to fix up that body's position on the celestial sphere. The declination will tell us how much north or south of the equinoctial that body is, and the GHA, Greenwich R angle, will tell us how much west of the celestial meridian of Greenwich that particular body is. So it will specify the position on the celestial sphere. Now, a second reference is also used in terms of specifying the meridian of the body. The second reference is used with respect to a particular position on the celestial sphere, which is known as first point of Aries. Now later on I will discuss with you the concept of ecliptic. Ecliptic is basically the path of the sun projected on the celestial sphere. Now this ecliptic cuts the equinoctial at two places, and these places are known as first point of Aries and first point of Libra. So if you use this first point of Aries as your reference and you measure the angle westwards of this first point of Aries, it is known as SHA, sidereal R angle. So these are the two references which we use to specify a body. Either we use the GHA measured from the celestial meridian of Greenwich, or we use the SHA sidereal hour angle, which is measured from the celestial meridian of first point of Aries. So this is the equinoctial system of reference on the celestial sphere. Important thing to keep in your mind is we should be clear about the concept of equinoctial. We should be clear about the concept of what a celestial meridian is, and with it we will be able to easily understand the concept of declination and GHA or SHA. So this is the equinoctial system of reference on the celestial sphere. So beta, I hope it is clear. Anything you wish to ask or share, you can do that.
Sir, you said about ecliptic, right? So is it the
That's
true sun or the mean sun?
okay. It is the true sun, beta.
True sun, no? Mean sun तो नहीं
That's
रहेगा.
right. That's right.
सर कभी कभी आवाज कट जा रहा सर, सिर्फ मेरे साथ हो रहा है या फिर बाकी लोगों के साथ भी?
What about others, beta? Are you getting any distortion in the voice?
नहीं सर, क्लियर आ
No,
रही है.
no sir, clear.
Negative.
Clear है sir.
No, clear.
Okay. Okay, beta. Great. So this was the equinoctial system of reference. Shall we move on to the horizon system now?
Yes, sir.
Very good, beta. Let's go. Now, having understood the concept of celestial sphere as well as the equinoctial system of reference, let's move on to our second very important system of reference, which is known as the horizon system of reference. So this is the second reference system which we use to specify the position of any celestial body on the celestial sphere. The position can be specified by the equinoctial system, or it can be specified by using the horizon system also. And the rational horizon which I talked about, the rational horizon diagram, is basically a combination of both these systems. So let us now concentrate our attention towards the horizon system. The diagram which you see right now on the screen is exactly the same diagram which we discussed in the equinoctial system. You can see the Earth in the center. You have the North Pole and the South Pole of the Earth. You see the equator marked here, and you see the axis of the Earth projected onto the celestial sphere, meeting at North Celestial Pole and the South Celestial Pole. Then you have the semi-great circle joining both the celestial poles. The green color semi-great circle which you see, that is the celestial meridian. And you see the equator projected onto the celestial sphere, giving us the equinoctial. So all these are the same items which we discussed in the equinoctial system of reference. So we are now going to add on the horizon system in this particular diagram only, so that we understand the concept, or we are able to combine them easily one by one. Now this horizon system of reference is dependent upon the position of the observer, or the position of the ship, where the observer is. If the observer changes its position, the horizon system references or coordinates also change. It is entirely based on the position of the observer. if you see the equinoctial system which we discussed earlier, for which you see all the references in this diagram, it has got nothing to do with the position of the observer. It is independent of the observer's position. The observer could be anywhere on the Earth's surface. The equinoctial is going to stay in this location only. The north celestial pole, the south celestial poles are going to stay at this particular location only. So the equinoctial system was totally independent of the observer's position. Now the horizon system is dependent on the position of the observer. So let us first of all specify the observer's position on the surface of Earth, and basis that position we will be able to find out the references used in the horizon system. So we have the observer at this particular location on the Earth surface, highlighted by the laser pointer. This is where the observer is. It is represented by O. You can see the observer written here in the diagram. Now what we are going to do is, from the center of the Earth, I am going to draw a line up to the observer's position, and I am going to extend that line on both the sides so that it goes and meets the celestial sphere. So starting from the center of the Earth, I am drawing a line which passes from the observer's position and meets the celestial sphere at this particular location. And the same line, if it is extended on the opposite side, you will see it will go and meet the celestial sphere at this particular location. Now these 2 points where this line meets the celestial sphere are our references for the horizon system. This line passing from the observer's position meets the celestial sphere at a particular point which we call as the zenith of the observer. So if you look carefully, you can also see that this zenith is going to be the point on the celestial sphere which is directly overhead of the observer. So if you look up to the sky, exactly upwards, totally upright in the middle of the sky, if you see overhead of you, the point which is there is the zenith of the observer. And this line extended on the opposite side, it meets the celestial sphere at a certain point which is called as the nadir of the observer. So zenith and the nadir, our 2 references for horizon system. So I'm repeating once again. If you draw a line from the center of Earth, passing from the position of the observer, extended up to the celestial sphere, the point where it goes and meets is known as the zenith of the observer. And the point diametrically opposite to it, or where the line extended in the opposite direction goes and meets the celestial sphere, is known as the nadir. Now we have the zenith and we have the nadir represented on the celestial sphere. Now we are going to draw what we call as the rational horizon. Now rational horizon is a great circle on the celestial sphere. A great circle on the celestial sphere exactly midway between the zenith and the nadir. So let's mark it in the diagram. You can see this blue color great circle represented in the diagram as the equinoctial. Sorry, as the rational horizon. My mistake. So rational horizon is a great circle on the celestial sphere exactly midway between the zenith and the nadir. You can see the relationship is quite similar to what we had between the celestial poles and the equinoctial. Equinoctial was located exactly midway between the celestial poles, Exactly in the same fashion, rational horizon is situated exactly midway between the zenith and the nadir of the observer. It can be defined in another wording, that is, a rational horizon is a great circle on the celestial sphere, every point on which is 90 degrees away from the zenith as well as the nadir of the observer. So this rational horizon is a very important reference for us as far as the horizon system is concerned. So we use the rational horizon as our reference, and we use these 2 points, the zenith and the nadir, as our references. Now, if you look carefully, the rational horizon basically divides the celestial sphere into 2 parts. That part of the celestial sphere which is above the rational horizon, you see, this particular part of the celestial sphere which is above the rational horizon is what will be visible to this particular observer. When he looks at the sky, he will be able to see that part of the celestial sphere which is above the rational horizon. To put it broadly, so that part of the celestial sphere which is above the rational horizon will be visible to the observer. And to put it broadly, that part of the celestial sphere which is below the rational horizon of the observer will not be visible to the observer. So this part is going to go below his horizon and it will not be visible to him. Now let's go forward from these 2 references. We have the rational horizon and we have the zenith and the nadir. Now let's try to specify a sense of directions basis the rational horizon. Now if you have the observer at this particular location on the earth surface, and let us say this observer is looking at the sky in the northerly direction, so he will have this north pole exactly front of him. Let us say you are on a ship which is moving on 000 course. You are steering true north 000. If you look towards the northern part of the sky, if you look right ahead, you will be able to see the north celestial pole or the Polaris, the pole star. So this north celestial pole or the direction of the pole star, if you bring it down to the rational horizon, this gives you the north point on the observer's horizon. So if you are on a ship which is steering 000, you can see the Polaris or the pole star. Now if you draw a vertical line coming vertically down from the pole star, the point wherever it hits the horizon, it represents the true north direction, 000 direction. Now exactly opposite to it. So for this particular observer, he looks at the celestial pole, the pole is here. He comes vertically down below that pole, and wherever it touches the horizon, that is the north point for him. Exactly opposite to it, exactly opposite direction, that means this particular direction will be the south direction. So let's represent it by a S. The north direction is represented by N, and exactly opposite to it we have the south direction. Now the angle between both these directions will be 180 degrees. They are diametrically opposite, the north and the south. So this is our observer looking toward this side. He is looking at true north or the north point of his horizon. Now if he goes 90 degrees to the right of the north, so if you go towards the right side from north, this is the right side, and if you go 90 degrees away on the right side, this point which you see on the horizon is the east point. You can visualize it on the ship also. Let us say you are on a ship which is steering 000. You are looking out of the bridge window. You are looking right ahead. The point which you see right ahead is the north point on your horizon. Now from that point, if you go towards the right or towards your starboard side for this particular ship, if you go to the right by 90 degrees, this is the easterly direction for you, or the 090 direction for you. So exactly same thing is represented here in 3D. The observer is here looking at the north direction, which is at this particular location. From north, going in the right direction by 90 degrees. This point, reference point, which we have on the horizon is the east point. Now, if you move towards the left side from the north point, starting from the north point, if you move towards the left side, if you move towards the left, 90 degrees away from the north point, wherever you will reach, is the west direction on your horizon. So these points which you see here, north, east, south, and west, represents the directions on the rational horizon. Exactly below the North Celestial Pole or the Polaris is the north point, and once you identify the north point, you will be able to correlate or identify exactly opposite to it. That point is south. From the north, you go 90 degrees to the right, you will find the easterly point, and from the north, you go 90 degrees to the left, you will find the westerly point. Now in this particular diagram, this is a 3D diagram. Now we have tried to show the full complete celestial sphere in 3D on a plane surface. We are trying to show a 3D object on a 2D surface. So that could be a little bit confusing, but when you are looking at the celestial sphere, you see this westerly point which you see, the west direction point, is the part of the celestial sphere which is towards us, or this part is towards the observer, and the east point which you see, it is on the far side of the celestial sphere which is opposite to us. So east point is on the far side of the celestial sphere, or on the other side of the celestial sphere, which is behind the screen you are looking at, and the westerly point is towards the screen, or the westerly point is towards you. When you are looking at the screen, the westerly part of the celestial sphere is towards you. So that's how this diagram is made. So we have these 4 reference points on the celestial sphere. Now let's go to another very important reference on the horizon system, which is called as a vertical circle. So what is this vertical circle? To understand this vertical circle, let us assume a celestial body. Let us assume there is a star which is visible to the observer in the sky. So let's mark this star in our diagram. You can see a particular star here in the diagram, which represents a celestial object. Now to show or represent the vertical circle of this particular body, let me show you in the diagram. Let's mark this body as X. So we have the celestial body, the red color star which you see labeled as X. Now let me draw the vertical circle passing through this particular celestial body. So you see this red color semicircle shown in the diagram is the vertical circle of this particular celestial body, this particular star. So once you see it in the diagram, now it will be very easy to understand what a vertical circle is. A vertical circle is a semi-great circle on the celestial sphere passing from the zenith and the nadir of the observer. So this is also very similar to the celestial meridians you see. The celestial meridians were semi-great circles passing from both the poles, the north celestial pole and the south celestial pole. Now in the same fashion, a vertical circle is a semi-great circle on the celestial sphere passing from the zenith and the nadir. Now zenith and nadir being diametrically opposite points, an infinite number of vertical circles can pass through them. Now what we are interested in is in the vertical circle passing through the celestial body. So in this particular case, when we have a celestial body, that is this red color star X, the vertical circle passing through this body is this red color semi-great circle. So vertical circles, I'm repeating once again, vertical circles are semi-great circles passing through the zenith and the nadir of the observer. And for our reference, we are interested in the vertical circle which is passing from the celestial body, which we are using for observation or sight taking. Now, once we have understood the concept of a vertical circle, we can now move on to a very important concept of the true altitude of a celestial body.
सर
Go ahead, beta.
सर एक चीज बता दीजिए सर, ये थोड़ा सा विजुलाइज नहीं हो पा रहा है जो आपने बोला ना सर, एंड द वेसल इज गोइंग ऑन 000 एंड व्हेन वी जस्ट इफ वी जस्ट लुक अप द स्काई दैट विल बी आवर नॉर्थ सेलेस्टियल पोल, करेक्ट सर?
राइट.
तो सर वो सर थोड़ा
लेट्स अज्यूम आप शिप पे हो, ब्रिज पे खड़े हो, इट इज नाइट टाइम.
जी सर.
यू आर लुकिंग इन द स्काई, आपको कोई भी सेंस नहीं है, डायरेक्शंस का कुछ भी पता नहीं है, नथिंग इज नोन. यू कैन सी द होराइजन. ओके, इट्स ए मूनलिट नाइट, सो यू कैन सी द होराइजन. अब आप पता लगाना चाहते हो कि इस होराइजन में नॉर्थ पॉइंट कहाँ है.
जी.
तो इसका एक बड़ा आसान तरीका है हमारे लिए. When you look in the sky, you will be able to easily identify, looking at the sky, where is the pole star or Polaris.
Yes sir.
Right? Big Bear या Little Spoon की जो constellation है, उसके जो आगे वाले दो stars हैं, they basically point in the direction of Polaris. So you will be able to identify where Polaris is. Right?
Yes sir.
अब अज्यूम करते हैं कि आपके पास एक मार्कर है जिससे आप स्काई में ना मार्क बना सकते हो. आपने वो पोलारिस के पास एक मार्क बना दिया. सो यू नो दिस पर्टिकुलर डॉट इज पोलारिस, राइट?
जी सर.
अब एक और काम करो, यू लुक डायरेक्टली अपवर्ड्स, बिल्कुल ऊपर देखो. नाउ व्हेन यू लुक अपवर्ड्स यू विल बी लुकिंग एट द जेनिथ, करेक्ट? सो आपने अब जेनिथ पे भी एक मार्कर लिया और मार्कर लेके आपने जेनिथ पे भी एक डॉट लगा दिया स्काई में. सो देयर आर टू डॉट्स इन द स्काई, राइट? अब आपने क्या किया, जो जेनिथ वाला डॉट था वहां से मार्कर चलाना शुरू किया, उसको लेके आए पोल स्टार तक, पोलारिस तक, और उसी को नीचे ले आए होराइजन तक. वो होराइजन पे कहीं ना कहीं जाके टच करेगा.
जी जी. यस
द पॉइंट वेयर इट टचेज इज द नॉर्थ पॉइंट फॉर यू.
Okay sir, got it sir.
Got it?
Yes, yes sir, got it.
Very good.
Okay sir.
अगर ये किसी को नहीं भी समझ में आया तो कोई टेंशन लेने वाली बात नहीं है बेटा, इसके
सर,
बिना
ये
भी
नॉर्थ
सवाल.
पॉइंट सिर्फ एक रैशनल होराइजन का नॉर्थ और साउथ ईस्ट वेस्ट है ना. दिस हैज नथिंग टू डू विद द नॉर्थ पोल, राइट?
नो नो नो, दिस हैज गॉट नथिंग टू डू विद द नॉर्थ पोल. पोल तो बेटा ऊपर कहीं भी हो सकता है.
एग्जैक्टली.
पोल तो जहां पोलारिस देख रहे हो एक्चुअली वहां पे है,
वहां पर है. उससे हमने जब 90 डिग्री आए तो उस हमारे होराइजन पे जो है वो नॉर्थ.
एग्जैक्टली. हमें अपनी होराइजन पे डायरेक्शंस की सेंस चाहिए. हमें पता है कि नॉर्थ पोल तो पोलारिस पे है, पर हमें अपनी जो होराइजन है ना बेटा, उस पे ना सेंस ऑफ डायरेक्शन चाहिए कि हम इस डायरेक्शन में जा रहे हैं या इस में जा रहे हैं या ईस्ट में जा रहे हैं, वेस्ट में जा रहे हैं. तो उसके लिए हमने होराइजन पे ये नॉर्थ ईस्ट साउथ वेस्ट पॉइंट्स को आइडेंटिफाई किया है.
सर ये पार्ट बी वाले क्वेश्चन में आता था ना, नॉर्थ ऑफ द ऑब्जर्वर, साउथ ऑफ द ऑब्जर्वर, ये रेशनल होराइजन का ही नॉर्थ साउथ ईस्ट वेस्ट है क्या?
हाँ, दैट्स राइट बेटा.
ओके सर।
अभी करेंगे सवाल, डोंट वरी, डोंट वरी अबाउट द क्वेश्चंस येट। सो ओके बेटा, चलें आगे चलें।
यस सर, यस सर। पहली बार सुना सर ये ना, ये वाली चीज बहुत कुछ नया नया सीखने को मिल रहा
अब बेटा मैं अगर चाहता तो मैं इसे कट भी कर सकता था। आई वुड हैव कट इट एंड स्ट्रेट अवे कॉन्फ्रेंस सिस्टम यूज्ड टू स्पेसिफाई द पोजीशन ऑफ द सेलेस्टियल बॉडी. So how do we specify the position? Now one of the terms which is used to specify the position of the body is the true altitude of the body. Now true altitude basically tells us how much above the horizon a particular body is. So let us see the true altitude in this particular diagram now. You see this red color dotted line represents the vertical circle passing from the body. Now this vertical circle is passing from the body. This vertical circle is also crossing the rational horizon at this particular point. Let's call this point as H. So you can see this H point shown in the diagram. This is the point where the vertical circle crosses the rational horizon. Now if you measure the arc of the vertical circle contained between the rational horizon and the celestial body. The arc of the vertical circle contained between the rational horizon and the center of the celestial body is known as its true altitude. Let me highlight this in the diagram. So you see this maroon highlighted arc from H to X. H is the point on the rational horizon and X is the center of the celestial body. So HX, the maroon highlighted arc, is the true altitude of this particular celestial body. So again, let me repeat the definition. You will be able to understand it now. The arc of the vertical circle contained between the equinoctial and the center of the celestial body, which is highlighted also by the laser pointer right now. Arc of the vertical circle contained between the rational horizon and the center of the celestial body is known as its true altitude. So you can see the true altitude labeled in the diagram now. We have the true altitude represented by HX, Hotel X-ray. Now once we have understood the concept of true altitude, it will be very easy to understand another term, which is the true zenith distance. Now you see, if you look at this vertical circle, at the rational horizon, it crosses the horizon at point H. Then if you move towards the body at point X, this vertical circle reaches to the center of the body. Now if you go further upwards from the body up to the zenith, now this arc of the vertical circle contained between the zenith and the center of the celestial body. Let me highlight it in the diagram. The green color arc which you see is the true zenith distance of the celestial body. So the definition, arc of the vertical circle contained between the zenith and the center of the celestial body is known as its true zenith distance. So you can see the TZD as green color arc highlighted as a part of the vertical circle. Now we know that from the zenith, if you go up to the rational horizon along any vertical circle, from the zenith to the rational horizon, the distance is 90 degrees. In fact, that is in the definition of the rational horizon also. It's a great circle on the celestial sphere, every point on which is 90 degrees away from the zenith as well as the nadir of the observer. So from the zenith Z point to H, which is on the rational horizon. This total arc is 90 degrees arc, and we know from H to X is the true altitude of the body. So it immediately tells us that the true zenith distance of the body, represented by this green color arc or ZX, will be equal to 90 minus true altitude. So you can see it labeled in the diagram. The true zenith distance of the body equal to 90 minus true altitude. So true zenith distance is equal to 90 minus true altitude, or in other words, you can say the true zenith distance plus the true altitude of a body always add up to 90 degrees. So we have understood the concept of true altitude now. We have also understood the concept of true zenith distance now. Very, very important concept from the horizon system point of view. So beta, any doubts coming to your mind up to here?
No.
Very good, beta. Great. So let's move ahead then. We have understood both the systems, the equinoctial system and the horizon system. The diagram may be looking little complicated, but don't worry, हम इसको भी simplify करेंगे and we will make a simple diagram. So let's go ahead. So all the things, new things which we discussed in the horizon system, they have been added up in the same diagram. The diagram now shows you both the systems. You see the equinoctial system also. You see the horizon system also. You see the references from the horizon system as well as the equinoctial system. Now, having understood both these systems of reference, that is the equinoctial system, which is based on equinoctial and the celestial poles, and the horizon system, which is based on the rational horizon and the zenith and nadir, or the vertical circles. We can now move on to understand the concept of PZX triangle. So we will use the two systems which we have just now discussed to understand what is this PZX triangle. So PZX triangle concept is what we use in celestial navigation to solve most of the problems. In fact, I would say the entire celestial navigation is based on the PZX triangle only. As I told you in the beginning that the concept of celestial sphere was assumed so that we are able to use spherical trigonometry to fix up the position of the observer or position of the ship using the spherical trigonometry formulas. These formulas are applied to the PZX triangle only. So let's go ahead and try to understand this. The diagram which you see on the right side includes only the things which we have discussed till now. We have discussed the equinoctial system. You see the equinoctial here. And you have both the poles. You can see the south celestial pole here. This is the north celestial pole. The semi-great circles joining them are the celestial meridians. You can see the celestial meridian represented here. Then you can see the rational horizon. Coming to the horizon system now. This is the rational horizon. You can see the nadir as well as this topmost point on the diagram is the zenith. Semi-great circles between the zenith and the nadir, they are known as vertical circles. So you see this particular vertical circle here. And this is the celestial body, the red color star which you see is what we are referring to right now. So if you consider this arc of the vertical circle contained between the horizon at point H up to the center of the celestial body, we just now saw that this is the true altitude of the body. So all these things we have discussed already. There's nothing extra here. And now we will try to see or find out the concept of PZX triangle, which is hidden in this particular diagram only. Now we know that this is the equinoctial, and the axis of the earth extended toward the celestial sphere. They meet at both the celestial poles. So this point here is the north celestial pole. Let's mark it as P. I have written NC also in short just to show it that this is the north celestial pole. This point is represented by P. We have seen this is the rational horizon. This is the position of the observer, and a line drawn from the center of Earth passing from the observer's position meeting up to the celestial sphere. It meets at what we call as the zenith of the observer. So this point is the zenith, and let us mark it as Z. We have the zenith point plotted on the diagram now. The celestial body's position is represented by X. So let's mark a X here. So we have the P point representing the north celestial pole. We have the Z point representing the zenith of the observer. And we have the X point representing the celestial body. And covered by these 3 points, that is P the pole, Z the zenith, and X the celestial body. This particular area which is covered by these 3 points is the PZX triangle which we are interested in. So you can see this PZX triangle on the celestial sphere, which we use to solve most of our celestial navigation based problems. Now let us try to go a little deep into the different parts of the PZX triangle. Now let's concentrate our attention to the Earth in the center. You see this circle here represents the equator, and this particular position, which is exactly on top of the Earth in our diagram, represents the observer's position. Now if you measure this arc between the observer's position and the equator, where I'm highlighting using my laser pointer, so this arc of the meridian between the equator and the position of the observer is the latitude of the observer. Angle at the center of the Earth, or the arc of the meridian contained between the equator and the particular position, is the latitude. Now equator is projected onto celestial sphere as equinoctial. You see this Q point is represented here. The Q point represents the position of the equator on the celestial sphere, and the observer's position is projected onto the celestial sphere at the zenith. So at this Z point is where the observer's position is projected. So this arc which you see from the Q point to the zenith of the observer represents the latitude of the observer. Now since Earth and celestial sphere are both concentric circles, whether you measure this arc on the surface of Earth or you measure it on the celestial sphere, the arc is going to remain the same. So ZQ or QZ is the latitude of the observer. Now we also know that from the equinoctial to the celestial pole, that is NCP. So pole to the equinoctial, P P to Q is 90 degrees. Every point on the every point on the equinoctial is 90 degrees away from the celestial pole. So P to Q is 90 degrees. Z to Q is the latitude of the observer, and this tells us that P to Z, this side of the PZX triangle, that is P to Z, will be 90 minus latitude of the observer. So let us highlight this side in yellow. You see the highlighted side PZ of the PZX triangle, and this is equal to 90 minus latitude, also known as colat. So PZ side of the triangle is equal to 90 minus latitude equal to colat of the observer. Let's also mark out the latitude of the observer. So you see equinoctial to the zenith, this arc represents the latitude of the observer. So we have labeled here as latitude on the diagram. So you can see the latitude ZQ and the colat P to Z, and both totaling up to 90 degrees. Pole to the equinoctial P to Q point is equal to 90 degrees. Now let's move to the other parts of this triangle. Now we move on to the PX side of this particular triangle, Papa X-ray. So this PX side, Papa to X-ray, is known as polar distance. You see X represents the celestial body and P represents the north celestial pole. So this arc basically tells us how far away from the pole the celestial body is. So this is known as the polar distance. Now this particular dotted line which you see going from the north celestial pole, passing from the star and going up to the south celestial pole, this dotted line is the celestial meridian of the star. You see, we discussed the celestial meridian in the equinoctial system. So this is the celestial meridian of the star. Pole to X to the south celestial pole, and this celestial meridian cuts the equinoctial at this particular point. Now from this point, if you measure the arc of the celestial meridian up to the body X, this particular stretch of the celestial meridian, what is this? This is the arc of the celestial meridian contained between the equinoctial and the center of the celestial body. This is the definition of declination. I told you declination basically tells us how much north or south of the equinoctial a particular body is. So if you look at this arc, it represents the declination of the celestial body. It tells us how much north of the equinoctial our celestial body is. And we also know that pole to equinoctial. So from the equinoctial, if you go along the arc of the celestial meridian up to the pole is 90 degrees. Every point on the equinoctial is 90 degrees away from the pole. So pole to equinoctial is 90 degrees. Equinoctial to the celestial body, this arc of the celestial meridian, is the declination that tells us that the PX side, which we call as the polar distance, will be equal to 90 minus declination. So I have highlighted this PX side with the maroon highlighter now, and this side is the polar distance of the body, telling us what is the distance of the body from the nearest pole, and this will be equal to 90 minus declination. So this is the PX side of our PZX triangle. So two sides of the triangle are understood. Now let's move on to the third side.
Sir, one question. Sir, can you mark the declination?
You want to mark the declination here, beta?
Yes, sir. Can you mark, sir, for
Okay.
understanding?
I will mark it in the next slide. But for now, beta, you are seeing this celestial meridian? Celestial meridian?
Yes, sir. Yes, yes.
Now,
X.
if you go from the center of the body X, along this celestial meridian up to the equinoctial, this particular arc is the declination. So
Okay, okay.
declination
It
is
is
the
not that. Okay, good. Not it is not the dotted arc, right, sir? From the star to the equinoctial.
uh, yeah, from the star to the equinoctial along the celestial meridian, not along the vertical circle. Okay, along the celestial meridian. So declination definition is basically the arc of the celestial meridian contained between the equinoctial and the center of the body. That is what declination is. Right,
Okay, sir.
beta?
Yeah, sir. That so where it will be cut, sir, on the equinoctial in this figure, the declination.
Ask again, beta.
I mean, where the dotted line will cut, sir, on the equinoctial from that
It is
body.
at this particular point, beta.
Oh, yeah. Okay, okay. Sir. That's what I'm
Okay, this is where it is
okay,
cutting.
sir. Means
Right?
cutting on rational horizon. Yes, sir.
No, no, no. Rational horizon is this one, beta. Rational horizon is the horizontal circle in our diagram. Okay, declination has got nothing to do with rational horizon.
Oh, okay, sir.
सर
So
ये
it will be from equinoctial.
सर्कल तो सर जेनिथ और नादिर से पास हो रहा है ना सर?
That is vertical circle. It is passing from zenith and the nadir. And the other dotted circle which you see, that is the celestial meridian, which is passing from the poles.
Yes sir, got it.
Right, beta? Got it?
Yes, sir.
सर ये x से लेके जो e के पास e के राइट साइड में जो डॉटेड कट कर रहा है x
Right.
से e के साइड में वो है ना सर डिक्लिनेशन?
No, beta, not along the E. It is okay. I'll show you in the next diagram. Don't worry. मैं दिखाऊंगा बेटा आपको.
ओके सर.
Okay. Now, if you move on to the third side of the PZX triangle, the third side passing from Z, going up to the X and going up to the nadir is the vertical circle passing from the body. This is the vertical circle which is passing from the celestial body. And we just now saw that the arc of the vertical circle contained between the rational horizon and the center of the body, that is h to x, is the true altitude. You see it is still marked in this diagram. This is the true altitude of the body. And we also know that any point on the rational horizon is 90 degrees away from the zenith. So z to h is 90 degrees. H to x is equal to the true altitude of the body. This tells us that z to x will be 90 minus true altitude. And this particular side is known as the true zenith distance of the body. In short, TZD of the body. So I have highlighted this side in green color. Let's label it as the true zenith distance, TZD, and it is equal to 90 minus true altitude. So 90 minus true altitude The side is the TZD, the true zenith distance, and it is represented as the ZX side of the PZX triangle. So you can see the PZX triangle here represented. P to Z is 90 minus latitude or co-latitude. Z to X is the true zenith distance or 90 minus true altitude. And P to X is the polar distance of the body, in this case 90 minus declination. So these are the three sides of the PZX triangle. So beta, can we move on to the making of the rational horizon diagram now?
So just one doubt. So declination also will be QS, right?
Declination will not be QX beta. I'll show you the declination. मैं अभी अगली slide में आपको declination दिखाता हूँ. Okay, so shall we move on to the next slide, beta? I hope it is okay. We can continue.
Yes, sir. This one is okay.
Yes, sir. Continue.
Right, beta, right. अगर break चाहिए होगा तो once we finish the rational horizon, then we can take a break, beta. No issues. So let's go.
Let's go, sir.
Now, having understood the concept of PZX triangle, we have first understood the equinoctial system, then the horizon system, and we are now able to see the PZX triangle on the celestial sphere. So let's now try to convert this PZX triangle to the rational horizon plane. Now this diagram which you see on the screen right now is exactly the same diagram picked up from the last slide. All the things which are mentioned here we have already discussed. You see this PZX triangle here. It is the same PZX triangle. PZ side is the colat 90 minus latitude. ZX side is the true zenith distance, which is 90 minus true altitude. The side HX represent the altitude of the body. And the third side PX is the polar distance, which is equal to 90 minus declination. Now it will be very difficult for us to make this kind of diagram. This is actually a 3D diagram represented on a plane surface. And for solving the questions which are based on the PZX triangle, if we need to make a diagram like this, it will be very, very difficult, hard, as well as time taking. Especially in the examination conditions, if you have to make this kind of diagram in every question, it will take a lot of effort as well as time. So to show all these things in a very simplified version, we can simplify this particular diagram by simply looking at it from a different angle or from a different perspective. Now, how do we look at it? Let us try to understand it now. First of all, you see, we are only interested in that part of the celestial sphere which is above the rational horizon. That means this particular part, which contains the PZX triangle also. This is the part which we are interested in. We are not interested in the bottom part of the celestial sphere that is below the rational horizon, because that in any case will not be visible to the observer. So we are not interested in this particular part. Now, how to have a perspective or angle so that this bottom part can be eliminated altogether and we are able to concentrate our attention to the top part. So for this, we visualize as if we are looking at the celestial sphere from top of the zenith. Right now we are looking at the celestial sphere somewhere from this west point, somewhere from this angle we are looking at it, but assume for the moment that you are able to go up to the zenith. Let's say you have a rocket accessible to you, you sit in the rocket, it takes off and it goes vertically upwards. Now, if that rocket goes vertically upwards, eventually at one point of time, it is going to reach the zenith of the observer. Now, we don't stop at zenith. We take the rocket still further upwards. Now, let's assume that the rocket has reached up to here. So once we have reached up to here, now we look down below towards the celestial sphere. So we are outside the celestial sphere now, and we are on top of the zenith, and you can say we are having a bird's eye view on the celestial sphere from top of the zenith. Like you see, many of the shots are taken by drones nowadays. So the drone flies high up in the sky and it takes a bottom picture, a aerial view. So that is what we are looking at it. So right now our eye, or we are situated at where the laser pointer is, and we are looking down at the celestial sphere. Now how does the celestial sphere appear? We will try to put it in a diagram on the right hand side of the screen. So in the blank portion now you will see how does the celestial sphere look from top of the zenith. Now first of all, the celestial sphere looking from top is going to look like a circle again. So it will appear like a circle as you see on the right hand side of the screen. Now when you are looking from top, you see this was the north point. The circle which we have made on the right hand side is basically the rational horizon of the observer. When you are looking from the top, the circumference of the celestial sphere will be the rational horizon of the observer. Anything which is below the rational horizon will not be visible to us. It will go on the far side of the celestial sphere. We will only be able to see what is on top of the rational horizon. So when we look at the celestial sphere, the circumference of the celestial sphere which we are going to look at is the rational horizon. So the circle which we have drawn on the right side of the screen represents the rational horizon of the observer. And that is why the name given to it as rational horizon diagram, because it is made on the plane of the rational horizon of the observer. Now you see we have this north point on the rational horizon. Now as per our sign convention, we show this north point on top of our rational horizon diagram. It matches up with our charts also. We have the north direction represented upwards. So here also in the rational horizon diagram, we represent the north direction up. Now exactly opposite to this north direction on the other side, you will have the south point. And if you go 90 degrees towards the right side of north, you will have the east point. And if you go 90 degrees towards left side of the north point, you will have the west point. So let us mark off these points in our rational horizon diagram. We have the north point here. If you go to the right side by 90 degrees, you will reach to the east point. So you see represented by E in our diagram. And if you go opposite to the north point, exactly opposite to where the north point is, exactly opposite to it, you will have the south point represented by S in our rational horizon diagram. And if you go 90 degrees to the left of north, you will have the west point represented by W here. So all these 4 points N, E, S, W represented on the plane of the rational horizon. Now you see, going from north up to the north celestial pole, from the north celestial pole going up to the zenith, up to Q point and up to S point. This is going to look like a straight line joining the N and S points. So if you have a look at this from top, it is going to look as a straight line joining the N and S points. So let's see it here. It is going to appear as a straight line joining the N and S points. Similarly, if you draw a vertical circle which will pass from the zenith and pass from the west point, this vertical circle passing from the zenith and the west point, and also a vertical circle passing from the zenith and the east point. So going from east up to the zenith and coming back to the west point will also look like a straight line when you look at it from top. So you see, this is the W to E vertical circle line which we visualized in the celestial sphere, and exactly in the center you will have this Z point. When you look from top, the circumference will be the rational horizon, and this Z point, that is the zenith of the observer, will be exactly in the center. So let us show this Z point exactly in the center here. You have the Z point here at the center.
सर डब्ल्यू ई फिर से बताना सर, कैसे बताया आपको?
W and E beta?
Yes sir, W E sir.
Okay. Beta, if you look at the north point, take your attention to the north point. From north, if you go towards right, 90 degrees away, that is where the east point is. Correct?
नहीं
East
सर,
point
वर्टिकल
is...
सर्कल आपने बताया ना अभी.
Okay. The vertical circle WZE.
Yes sir.
Okay. Now beta, if you look at a vertical circle passing from the zenith and passing from the W point. Okay. All the vertical circles, they pass from the zenith and the nadir. So imagine a vertical circle passing from zenith and the W point. Okay. If you are looking from top, it will look like a straight line, and it will be exactly as the ZW line which you see on the right hand side. In fact, any vertical circle you draw, it will appear as a straight line or a radial line in the rational horizon diagram.
Okay sir.
Are you able to visualize better?
Yes sir, yes.
Okay, great. It'll keep on becoming clear as we go further. Now from Z, if you move towards the south point, from Z moving toward the south point, once you cover an arc equal to the latitude, you reach up to point Q. So let's mark off this Q point in our rational horizon diagram. So from the zenith, when you move towards the S point and you move a distance equal to the latitude, you reach up to the Q point here. So from the zenith towards the south point, we moved an arc or distance equal to the latitude, we reached at Q point. So this Q point represents the Q point here in this diagram. Now if you look carefully, From the Q point, if you join up the W point, W to Q, and moving further Q to E, this particular arc, E point to Q point to W point, represents the equinoctial. So we can also show the equinoctial in our rational horizon diagram now. You have the W point here, you have the Q point here, and you have the E point here. So joining W to Q to E will give us the equinoctial. So let us do that. So you see W joined with Q joined with E gives us the equinoctial. So this WQE represents the equinoctial in our rational horizon diagram. This WQE you can see here in the celestial sphere diagram. This is point W going up to point Q, going up to point E. Only this part of the rational horizon will be visible to you. If you go beyond W on this side, or you go beyond E on this side, this is going to fall in the far side of the celestial sphere, which will not be visible to us. So this will not be visible to us. So that's why you only see half of the equinoctial, which is visible to you as WQE in our rational horizon diagram. Now let's proceed ahead. Let's come back to the Z point. From the Z point, if you go towards N point, towards the north point is here. So from Z, if you move towards the north point, equal to a distance which is your colat or 90 minus latitude, you will reach at the north celestial pole. So let us show this in our diagram now. We start off from the Z point, we move towards the north point, and we move a distance equal to 90 minus latitude or our colat. The point where we arrive is the north celestial pole. It is represented by P. So let's mark this as P here. You can see the north celestial pole shown in our rational horizon diagram. Let's mark off the arc P to Z also. So this is marked in yellow, exactly same as was marked in the celestial sphere diagram. So you see P to Z was marked as yellow, and it has been marked as yellow in the rational horizon diagram as well. This is equal to 90 minus latitude or equal to the colat. Now let's take our attention to celestial sphere diagram. From the Z point, if you draw a vertical circle passing through the body is here, that is star X. So from the zenith, if you draw a vertical circle passing from the body, going up to the rational horizon to point H and going up to the nadir, this is the vertical circle passing from the body. Now if you look from top, this vertical circle is also going to look like a straight line. And how will this look? From the zenith, you see this particular dotted line. This is how this vertical circle is going to appear. The point where this vertical circle touches the rational horizon, you see the vertical circle from Z going up to X touches the rational horizon at point H. This point H is going to be this particular point here. From the zenith going up to the rational horizon, this is the H point. Again, Somewhere in between the Z and H points, you will have the celestial body, that is the star, which is represented as X here. So let's mark the celestial body also now in our rational horizon diagram. So somewhere between Z and H, we will have the celestial body shown here in the rational horizon diagram, represented by X. You can see the celestial body here. Now you can see H to X is the true altitude of the body. So concentrate on the celestial sphere diagram. You see X to H highlighted in the maroon color. You have the true altitude of the body. The same true altitude is represented H to X in the rational horizon diagram. So let's mark it with maroon color, highlight it with maroon color here also in the rational horizon diagram. Now going back to the celestial sphere diagram, you see Z to X. This is the true zenith distance of the body, which is 90 minus true altitude. So let's show it here. Z to X. Let's highlight it also with the green color. You see Z to X is the true zenith distance of the body, and it is equal to 90 minus true altitude. Another important thing in the rational horizon diagram, you see the zenith is at the center of the rational horizon plane diagram, and the circumference which you see of this particular diagram is the rational horizon of the observer. Now we know every point on the rational horizon is 90 degree away from the zenith. So this indirectly tells us that the radius of this particular diagram is 90 degrees. That means from Z, if you go to the rational horizon in any direction, it will be a 90 degree arc. So from Z, if you move towards H, Z to H is total 90 degrees. H to X was the true altitude of the body. That tells us Z to X, that is the green highlighted arc, will be equal to 90 minus true altitude. You can compare it with the celestial sphere diagram also. Z to H, zenith to horizon, was 90 degrees. H to X was the true altitude of the body, and Z to X is equal to the true zenith distance, which is 90 minus true altitude. So we have two sides of the PZX triangle now plotted in our diagram. Let's move on to the third side now, that is P to X. So this third side, which is P to X, going further to the south celestial pole, is the celestial meridian passing through our star. So we have to basically draw the celestial meridian of the star. So pole to X. So let's come back to the rational horizon diagram. This is the pole, and this is the celestial body, the star X. And we have to draw the celestial meridian now. So let's draw it. This celestial meridian is going to appear like this. This is how the celestial meridian is going to appear. So you see, passing from the pole, going further up to point X, and eventually going up to the rational horizon. This represents the celestial meridian of the body. Now the celestial meridian of the body cuts the WQE line. WQE line is the equinoctial at point D. Now you can look at it in the celestial sphere also. Celestial meridian from the pole going up to the body X goes up to the equinoctial at this particular point. So this point here is the D point referred to in our rational horizon diagram. This is the D point in the celestial sphere diagram, and it is referring to this D point on the rational horizon diagram. Going further from D, at this point it crosses the rational horizon, and if you see here, going further from D, at it reaches this particular point, it will cross the rational horizon and go on the far side. So we have the celestial meridian of the body drawn now. Now let's mark off on this celestial meridian. From the equinoctial up to the body D to X, this basically represents the declination of the body. How much north or how much south of the equinoctial a particular body is what is its declination. So the arc of the celestial meridian contained between the equinoctial and the center of the body is the declination of the body. So dx is the declination. You can correlate it in the celestial sphere diagram also. D point on the equinoctial, X point the celestial body, D to X is the declination. Now coming back to D point in the rational horizon diagram, we know from the equinoctial, that is D point, to the pole, that is P point, is always 90 degrees. Every point on equinoctial is 90 degrees away from the pole. So D to P or P to D is 90 degrees. D to X is the declination. That tells us that P to X will be 90 minus declination. The arc which is highlighted in maroon color now, it will be 90 minus declination, and it is the polar distance of the body. You can correlate it to the celestial sphere diagram also. You see, D to X was the declination, X to P is the polar distance, which is 90 minus declination. So you can see now all the three sides of the PZX triangle shown in the rational horizon plane. So as you can appreciate looking at both these diagrams, that diagram made on the plane of the rational horizon is much simpler and easier to make, and you will be able to make it in much lesser time as compared to the celestial sphere diagram on the left hand side. So this is the reason why we use the rational horizon diagram so diversely, so randomly, to solve the celestial navigation based problems.
So are we going to draw the declination circle also?
Say again, beta.
So, generally, x is our body, right? And dx is the declination. So, usually, are we going to draw the declination circle also, which runs almost parallel to the?
Yes, we can draw it. I have not shown in this diagram, otherwise it will become complicated. But when we make the rational horizon diagram, we will be showing the declination circle also. The declination circle will be exactly parallel to the equinoctial, that is WQE. So passing from X parallel to WQE will be the declination circle of the body.
Okay, sir.
Okay, beta. Great. So things looking okay now?
Yes, sir.
वेरी गुड बेटा, ग्रेट।
Yes,
अब
sir.
मुझे
Go
बस
ahead.
एक छोटी सी चीज और बतानी है मुझे, दैट इज बेसिकली द टू एंगल्स, एंगल Z एंड एंगल P. सो लेट मी एक्सप्लेन दैट. Now beta, going little more deeply into the PZX triangle, we have seen all the three sides of this triangle. One side, the PZ, the yellow color side, is the colat, which is 90 minus latitude. The green color side, ZX, is the true zenith distance, which is 90 minus true altitude. And the maroon color side, which is PX, is the polar distance equal to 90 minus declination. Now we are also able to identify and find out two of the angles of this particular triangle. Now the first angle here which we see, or which we are able to easily correlate and find out, is angle P in this PZX triangle. Now if you look carefully, the line PZQS represents the meridian of the observer, the celestial meridian of the observer. So pole to zenith to Q point to S point represents the celestial meridian of the observer. And if you see the side P to X to D, this particular side is the celestial meridian of the heavenly body of the stars. So this particular angle which you see here, that is angle P, is the angle between the celestial meridian of the observer and the celestial meridian of the body. And this angle is being measured in this particular direction. So you are measuring this angle in this particular direction, which is this direction. This direction, you can have a look here. This represents the westerly direction. The right side in this diagram, this part you see here, represents the easterly direction, and this side represents the westerly direction. So angle P is the angle at the celestial pole contained between celestial meridian of the observer and the celestial meridian of the body measured westwards. This is the definition of LHA, local arm angle of the body.
Sir, can you repeat, sir, once again, sir, please, sir, the definition?
Yeah, I'll repeat, beta. Angle at the pole contained between the celestial meridian of the observer and the celestial meridian of the body measured westwards. That is the LHA, local R angle.
Okay, sir.
Right, beta? Chale aage?
Yes, sir.
Okay, great. Angle at the pole contained between celestial meridian of the observer and the celestial meridian of the body measured westwards. So this angle is the LHA. So we have identified angle P of the PZX triangle. Let's move on to another angle now. Let's concentrate our attention on angle Z. Now if you look at angle Z, this is the angle between the celestial meridian of the observer. You see PZQS is the celestial meridian of the observer, and the vertical circle passing from the body. Now this angle is the azimuth of the body. So let me represent it in blue color. You can see this particular angle here. This is the definition of azimuth. So the angle between the celestial meridian of the observer and the vertical circle passing through the body is the azimuth of the body. You can visualize here, beta, the angle, this angle basically gives us the direction in which the body is. The side PZ or NPZ represents true north, and the side ZX represents the direction in which the celestial body is. So you see, this particular angle tells us what is the direction of the body with respect to true north. And if you look little more carefully, you will understand that this is the quadrantal azimuth of the body, or the azimuth of the body in the quadrantal notation. In this particular case, the body is northwest of the observer. You see, this is the end point represents the north direction. The W point represents the westerly direction. So this body is somewhere in a direction northwest of in the northwest quadrant of the observer. So the azimuth which this angle Z gives us is the quadrantal azimuth of the body. North so many degrees west is the azimuth of this particular body. So we have identified angle Z in this triangle. So these are the two angles which we can find out in this PZX triangle. So two angles have been identified and all the three sides have been identified. Now the only unknown item which we are not interested in, that is angle X. This is the angle at the celestial body. We do not use this angle in our calculations, nor can we find it from this diagram. We don't require it. If we need, we can find it, but we don't require this angle anywhere. So this angle is usually left unknown, and neither it is used nor it is found out. This angle is not required in the calculations. So we have the PZX triangle understood. We have understood all the three sides of the PZX triangle. We have seen the two angles of this particular triangle.
Sir, by looking at this diagram, sir, can we correlate the similarities between P and LHA, I mean direction?
बिल्कुल बेटा, exactly. ये तो डायग्राम जो है ना, ये मैजिकल डायग्राम है. इससे आप कुछ भी कोरिलेट कर सकते हो. यू रिमेंबर वी कैलकुलेटेड P व्हेन वी वर डूइंग द LHA कैलकुलेशन. लॉन्ग बाइक्रोन में भी हमने P निकाला. I told you P is equal to LHA if LHA less than 180, right? So in this diagram,
Yes,
you can clearly see if the LHA is less than 180, P will be equal to LHA. And if the LHA becomes more than 180, that means the triangle is being made on the eastern side. And in that case, the angle P will be 360 minus LHA.
yes, yes.
Right, beta?
Yes, sir.
Very
Sir,
good.
this
beta.
point H, sir, this point H on the rational horizon, how will we identify that where we will take the point H?
You don't need to identify that, beta. When you take the bearing of the body by using your azimuth circle, when you take the bearing of the body, or if you calculate the azimuth of the body using ABC method, automatically you will come to know what is the direction of point H.
Okay, for the diagram purpose, we can take anywhere, right, sir?
Yes, beta. If they have given you the azimuth of the body, let us say it is given. If they tell you the azimuth is 280, you know W point is 270, N point is 360. So 280 has to be slightly above the W point here. So given the azimuth, you can mark the H point anywhere required as per the azimuth in the diagram.
Okay, sir. Oh, okay.
Sir, can you please tell for the LHA one time more?
Okay. Now, beta, this angle P of the PZX triangle is equal to LHA if LHA is less than 180. And if LHA becomes more than 180, that means the body has come to east of the observer's meridian. In that case, the diagram would be made on the right side of the rational horizon, east side of the rational horizon, and in that case, P will be equal to 360 minus LHA.
Okay, sir.
ओके बेटा, और बताओ बेटा, और क्या डाउट्स आ रहे हैं?
Okay, sir, go ahead.
Sir, have you made this diagram for declination less than latitude by any case?
बिल्कुल बना देंगे बेटा, जैसी आप बोलोगे वैसी बना देंगे.
No, sir, this is the one. No. Actually, what you have drawn on the right hand side, it looks
Right.
like declination less than latitude, right?
Yeah, it will be less than latitude.
Okay.
So समझ गया बेटा, clear?
Yes, sir. No.
Yes,
Very
sir, go
good.
ahead.
Excellent. बस बेटा अब go ahead हो गया. अब this topic is complete now. If you have understood this much, then the rational horizon. So slowly छोटी छोटी चीजें और हैं जो हम cover करते जाएंगे and we will keep on doing these questions. Right? Okay. अब बेटा मुझे ये बताओ, हमारे पास अब दो ऑप्शन हैं. अब बोलो बेटा.
सर एक्चुअली एक चीज मुझे पूछनी थी. व्हेन बाय यूजिंग लॉन्ग बाय क्रोन वी फाइंड आउट द पी. तो सर उसमें कभी कभी व्हेन द साइट इज बिफोर मेरिडियन पैसेस वी हैव टू लाइक 360 माइनस पी करके एलएचए निकालना पड़ता है. तो सर वो
That's
क्यों
right.
करते हैं एक्चुअली?
ओके बेटा, अभी बता देते हैं. Now beta, if you look in this diagram, meridian passage means the body crossing PZQS. This is the observer's meridian. When the body is here, that is what we call as meridian passage. The body will be rising on the eastern horizon, close to east point, then traveling in the sky, crossing the meridian at a certain point, and then moving to the western side. Now before Marpas, you see body is east of the observer's meridian, right beta?
You're right, sir. On the right side, on the eastern side.
Yes. So when the body is on the eastern side, this triangle will be made on the right side also. Correct, beta? Triangle will be made on the right side. And if you see now,
right, sir.
the angle P of that triangle, which is made on the right side, will not be equal to LHA. LHA is always measured westwards. Whether body east of you or west of you does not affect the LHA. LHA will be measured westwards. It will be more than 180 in that case. And you see angle P in that case will not be equal to LHA. It will be equal to 360 minus LHA. Right, beta?
लेकिन से पता कैसे चलेगा लाइक साइट इज बिफोर मेरिडियन पैसेज साइट? कैसे मतलब कि देख के कैसे पता चलेगा?
आएंगे ना, तो कहीं ना कहीं से हमें कोई ना कोई हिंट जरूर मिल जाएगा, या तो उसका एजीमुथ दिया होगा. अब अगर बॉडी का एजीमुथ इज बिटवीन 0 एंड 180, एजीमुथ ऑफ द बॉडी इज बिटवीन 0 एंड 180, नॉर्थ ईस्ट में बॉडी है या साउथ ईस्ट में बॉडी है, इट इज ईस्ट ऑफ द मेरिडियन. If the azimuth of body is greater than 180 up to 360, it is west of the meridian. So कोई ना कोई हिंट हमें क्वेश्चन में जरूर दिया होगा जिससे ये पता चल जाए where the body is. Right?
Yeah, that's correct.
Okay.
कभी भी सर azimuth 90 और
बेटा speak again.
azimuth सर कभी भी 90 और 180 के बीच में देंगे सर?
Yeah, it can be beta. Azimuth can be anything. It can be between 90 to 180 also.
Okay sir.
Okay, it can be any value between 0 and 360.
Sir, can you explain the amplitude, sir? Amplitude definition from this diagram?
तो ये हम आ गए हैं रैशनल हॉराइजन डायग्राम पे. कोई एक लैटिट्यूड बता दो बेटा ऑब्जर्वर का. एनी लैटिट्यूड ऑफ योर चॉइस.
Sir, 25 degree north.
Okay. So latitude is 25 north. Latitude is 25 north. That means zenith has to be north of the equinoctial. That means equinoctial will be south of the zenith. So let us make point Q somewhere here. This is Q point. Equinoctial will pass from W to Q to E. We have the equinoctial. Let's make the pole also. Pole will be on this side. Observer north hemisphere में है, north pole हमें दिखेगा. So let's mark the pole. अब बेटा कोई भी एक डेक्लिनेशन बता दो, any declination of your choice of the body.
Sir, 35 degrees south.
35 south is the declination. Okay. So Q point is the equinoctial. I go 35 degrees south. That means the body will be somewhere here. Okay. This is declination. Let me show. This is the declination. Mark it with D. Now let us make the declination circle of the body. Declination circle will pass from this point and it will be parallel to the equinoctial, something like this. This body is going to rise at this particular point. Let us call it point A. Body will be rising at A. At point Bravo, body will be crossing the observer's meridian. And at point Charlie, the body will be setting. Motion of the body will be like this. Clear, beta? Up to here, clear?
Yes, sir.
Very good. Now, what do you want to show? Amplitude?
Yes, sir. I'm good.
Very good. Amplitude means rising or setting direction or bearing of the body. So, which one you want to take, rising or setting?
Rising.
Rising. So, body is rising at point A. Let us join Z with A. So, you join Z with A. This angle here, beta, this particular angle is the amplitude. This is the rising amplitude of the body. East so many degrees, south will be the amplitude.
Okay, sir. Thank you.
और बताओ बेटा, और कोई चीज क्या शो करना है? अब तो एक बार आपको ये आ गया. This is your playground now. You can do anything on this diagram. So बनाना है बेटा, और कुछ बनाना है?
सर रेस्टल होराइजन के डायग्राम में जो डेक्लिनेशन आप दिखाए थे वो मेरिडियन टाइप दिखाए थे सर, आर्क टाइप. और
बिल्कुल
इसमें
बेटा, अभी दिखा देते हैं. Actually, star can be anywhere on this A to C. ABC में star कहीं भी हो सकता है. So if you assume that the star is here at this particular point, so अब हमें star का बेटा celestial meridian draw करना पड़ेगा. So let us draw the celestial meridian. ये हमने celestial meridian draw कर दिया. Now from the equinoctial up to the star, this is what is declination. Basically ये जो बैंड देख रहे हो ना आप बेटा, ये बैंड, ये डेक्लिनेशन शो कर रहा है. इसे कहीं भी मेजर किया जा सकता है. All these will be the declination of the body. Right बेटा?
एम्पलीट्यूड की डेफिनेशन क्या है सर?
एम्पलीट्यूड की डेफिनेशन देखो बेटा, amplitude is the angle at the zenith contained between the prime vertical circle of the observer, which is WZE, and the vertical circle passing through the body. इनफैक्ट अगर ये डायग्राम आपके सामने हो तो आपको कोई भी डेफिनेशन याद करने की जरूरत ही नहीं है. इसमें से सारी की सारी डेफिनेशन बाहर निकल के आएंगी ऑटोमेटिकली. So I'll repeat once. Amplitude is the angle at the zenith contained between the prime vertical circle and the vertical circle passing through the body. Right, beta?
Sir,
Okay,
prime
sir.
prime
Okay,
vertical
sir.
circle means great circle passing through equinoctial, right, sir?
I will
Great
tell you,
circle
beta.
passes
I'll tell
through
you.
east of rational horizon.
Let me highlight the prime vertical circle here. Let us pick up green color. बेटा ये जो ग्रीन कलर का WZE वर्टिकल सर्कल देख रहे हो आप, दिस इज द प्राइम वर्टिकल सर्कल WZE, राइट?
Yes.
एंड एक और वर्टिकल सर्कल होता है, वो भी मैं आपको दिखा देता हूं. लेट अस मार्क इट इन येलो. दूसरा इंपॉर्टेंट वर्टिकल सर्कल होता है ये वाला बेटा, N2Z2S. इसे क्या बोलते हैं?
Principal.
Principal
Principal
vertical.
vertical.
Very good, beta. Very
Principal
good.
vertical.
This is called as principal vertical circle. Yellow one NZS, principal vertical circle. Green one WZE, prime vertical circle.
Okay, sir.
सर तो प्राइम वर्टिकल हो गया, इट्स अ वर्टिकल सर्कल पासिंग थ्रू ईस्ट वेस्ट ऑफ रेस्टल.
That's right, beta. और principal vertical?
It's a vertical circle passing through north south of the western horizon.
लो बेटा, ग्रेट. तो सारी डेफिनेशन तुमको आ गई यार. ग्रेट बेटा, वेरी गुड. So comfortable beta?
Yes, sir.
Off now beta. We are done for today. Target achieved. Next lecture when we meet, I will be covering up with you the question on stars suitable for sight. This is question number 7 of